So this is a web-based technology webinar series, and the title, Why You Should Learn Go. My name is Andrew Scopa. I'm the author of a course called Go Programming Language Essentials. And a little bit about my background. I have been in the software engineering field for several decades, about 4 decades now. And so I've worked in various capacities as a software engineer, an instructor, an author of books and courses, as well as a project lead, a manager, and a business owner. I've worked with numerous different languages, probably 15 or so over the span of my career. And over the past 10 years or so, I've primarily focused in C++, C#, Java, JavaScript, Python, TypeScript, languages like that, along with technologies, including Node.js and the .NET framework by Microsoft. About 3 or so years ago, I was offered the opportunity to teach a course in the Go language, which I had dabbled in. And I was at first reluctant because I had no real experience with the language. And I didn't want to spend an inordinate amount of time learning a totally new language, since I knew so many. And some languages come and go. But the more I learned about Go, the more excited I became. So now, over the span of the past 2.5, 3 years, it's been one of my primary areas of focus, to the point where last year I decided that I would write my own course, and it was just completed within the past few weeks, in fact. And we've run it once, and a very exciting topic. But we're going to be covering in the next hour an overview of the history of Go, its origins, what the designers' motivations were behind the language, as well as the designers' backgrounds in particular. We're going to review some code samples that discuss the different aspects of programming with Go. So procedural, object-oriented, functional, and CSP style of programming. I'll talk about how to install and use Go. And then when we wrap up, I'll spend some time answering any questions you might have as to the Go language. So a brief history of Go. Go was designed at Google about 13 years ago, originally designed to improve programming productivity. It was back in the time when we started having multi-core CPUs and computers that had 32, 64 processors and some even more. And we wanted the goal was to have applications that could take advantage of that extra processing power. The language was publicly announced in November of 2009, and from that point, 2012, version 1 was released, and in August of 2015, Go 1.5 was released, and that's when it really began to take off in popularity. In fact, now it's one of the most popular languages to learn, and it's widely being used by a number of different very large organizations and numerous Go projects, including Docker and Kubernetes, amongst others. Of course, the language is designed at Google, so it's widely used in production code at Google as well. So I had the foresight to save the original web page of the Go introduction back in November 10th, 2009. Just kidding. But what you see is that the description says that Go is fast, safe, concurrent, fun, and open source. And it still follows those primary goals in that it's fast, very quick to execute, it's safe, security in mind, concurrent, which we'll talk about, communicating sequential processes. It's fun, easy to learn, similar to learning a language like C++ or Python, but more in line with the C style of programming. So I like to call it the modern C, and it's open source, which makes it widely accessible without cost. So the designers, very important here. Whenever you look at a new language, you should typically look at the authors or the designers behind the language, and that will give you some insight as to the lifespan of the language. Was it introduced by a team of developers at a major organization with a lengthy background in the industry? Well, in this case, the answer is yes. Ken Thompson, for example. Ken Thompson was a computer scientist that worked at Bell Laboratories for most of his career, and he actually wrote the code for the Unix operating system. So he worked alongside with Brian Kernighan and Dennis Ritchie, who were the designers of the C programming language. There's also Robert Pike. He's best known for his work on the Go programming language, so he was one of the key participants. And at Bell Labs, where he was a key member, a principal of the Unix team. And Robert Greismeyer, he's also one of the key designers, an employee of Google, and was one of the initial designers of the Go programming language. And he also at Google worked on the V8 JavaScript engine, which then became known as Node.js. It was the foundation of Node.js. So why was there a need for a new language? Well, the designers, in particular Ken Thompson, were motivated by their disdain or dislike, probably a nicer word, of C++, because C++ is very complex, very difficult to debug with issues regarding memory leaks and so forth, along with the fact that there was no internal memory management facilities. All of the plumbing had to be built by hand with few exceptions. So as part of the original design, the discussions were meant to be consensus driven. In other words, the parts of the language that would be included had to be unanimously considered as being the parts of the language which would eventually become production. So features were accepted only when all three authors of the language agreed. And to avoid bloating, most of these proposed changes were rejected. Now, interesting, there's a quote by Ken Thompson. When the three of us got started, it was pure research. And we got together and decided that we hated C++, disdain, dislike, hated, probably a very strong word. We started off with the idea that all three of us had to be talked into every feature of the language. So there was no extraneous garbage put into the language for any reason. So it's a very trimmed down, lightweight, not overly bloated with extraneous features that you'll find in other languages. Now, it turns out that I happen to be a fan of many languages, for example, C#, but C# continues, it's by Microsoft, by the way. C# continues to grow in its capabilities, you know, the feature of the day, so to speak, which is great, but the learning curve is always extending. Here, you learn the key aspects of a language, and from that point, your knowledge base is solid. Now, is that to say that the language won't change or evolve? Yes, of course it will. For example, we're still in version 1, and version 2 is on the horizon. But for now, let's just say that it is a small language, easy to learn, and if you have a background in a language such as C, C++, Java, C#, it would be very easy to pick up. It is not a scripting language, so you'll find that it's different than Python or JavaScript, but and that's because of the fact that it's a compiled language. So what is Go? By the way, the name of the language itself is Go, but it's frequently given the name Golang. In fact, I always tell people that if you are looking for help on any feature of the language in a search engine, type in Golang followed by the topic, and that will bring you your key results to the top of the list. So first of all, it's high-level language, and it's open source, as I mentioned. It's statically typed, which means you have compile time type safety. Now, that's unlike scripting languages, which are dynamically typed. It's also very runtime efficient. The compiler optimizes the instructions for runtime execution. It provides all of the built-in plumbing that we would otherwise have to deal with in some other languages, primarily C++ and C. For example, there's built-in memory safety, garbage collection, structural typing, and also one of the key features of the language is that it provides what's known as CSP-style concurrency. That stands for communicating sequential processes. And your programs are compiled. It's a compiled language, and they're assembled by using what are called packages. Okay, packages allow you to build the application into pieces like modules that provide a context for accessibility, shareability, and the language itself has, along with its own built-in key features, a large standard library, plus access to third-party libraries, of which there are many. For example, if you were interested in using Go with something that might be used in another environment, do a search on the internet and you will probably find a library that will help you out. Okay, for example, working with SQLite or SQL Server or Oracle, things like that, there are libraries that are available to help you with that. One of the languages, one of the technologies that I specialize in for database access is a NoSQL implementation of MongoDB, and there's a library to help us with that. It also supports key common programming methodologies. Although the designers wanted to break away from the shell of object-oriented programming, they removed some of those features. They did provide the common newer programming methodologies that most programmers expect to find in a new modern language, as Go is. Okay. Now the language itself, as you'll find, is I will be showing you shortly, is very heavily influenced syntactically by the C programming language. Now, don't let this scare you if you don't know anything about C, because a majority of the programming languages that are currently in use belong to the C family, and that would include, interestingly enough, even JavaScript, Java, C++, and the like. Okay, they all have some of their roots in C. Okay, so we'll start off with the fact that Go, in my opinion, and it's a fact in this case, is a procedural programming language. So I put here a blurb right out of Wikipedia that describes, in their terminology, in general terms, what a procedural programming requires to be considered to be procedural. So I want to adapt that to my words, which says a procedural programming language takes a top-down list of instructions approach, okay? And it utilizes functions to achieve program structure and reusability. So in Go, a procedural application would look like this. I mentioned packages, and there's always going to be one main package that will comprise the application entry point. So you have a package called main, and from there we'll import the libraries that contain the procedural instructions that we will take advantage of in our code. Now, in addition to the functions, procedures that we would find in these other packages, we will also find other things that I'll be discussing shortly. So here we have an entry point, which is func main, and in here we're just setting up variables whose values will be set from invoking or calling functions found in another package. So over here I have a package which I just happen to name utils, for lack of a better name, and I define some data types. I have two functions that I'm calling. A couple of interesting things here. First of all, const, in this case here, is invisible to the main application code. And the reason for that is the name company here, which represents a constant identifier, is lowercase. So Go enforces encapsulation and visibility outside of a package by the lower uppercase for the first letter of the identifier name. And so you'll see that here with get welcome message. Get welcome message as well as get company, both begin with an uppercase letter, so they are accessible. to the calling external package here. And when I run this code, it will print out the message and some message to the screen, some welcome message. So by the way, I mentioned procedural. So the procedural aspect of this is not just the functions that I wrote, but also the fact that I'm importing functions from the built-in Go library. So FMT, which has formatting procedures that are similar to C, printf, scanf, and things of that nature. But the webinar utils would be my package. Okay, so this is inside of a folder under a root called source that where the root of my application begins in a folder called webinar, and in the containing package, I am a subfolder of webinar called utils. And notice the naming coincidence here. Utils is the name of the folder, and my package is called utils. So that's sort of the approach that's taken with respect to the language. Everything is organized into packages, and we follow a structural, hierarchical convention for the files within the packages. So object-oriented. Now this is interesting. So Go itself is not like other languages in that it does not provide us a way to build inheritance hierarchies in the true sense. So there's no what's called forced implementation inheritance that couples the code in your application to be associated with some external contract. Instead, they do provide us with what are called interfaces. Through interfaces, we have what's known as interface inheritance, but there's not a tight coupling or association by the source and the contract. Now, I'm not going to teach you this. Obviously, I'm just giving you a very high level overview of the language, but it's one of the key aspects of the languages, and that they moved away from the coupling that other languages find. Okay, so as before, I included at the very top here a blurb out of Wikipedia, and I may have added it slightly just for the sake of screen real estate space. Okay, but in my words, in general terms, object-oriented programming is basically a model or of a real world type system. Use define types to system where you have operations known as behaviors, and then data, which represent the properties of a type. And then through hierarchies, we can reuse code. And so object-oriented program is responsible for hiding data and exposing behaviors. So Go provides a layer of support for object-oriented programming using some of the built-in types. For example, structs are the primary way in which you build an object-oriented system in Go. Not the only way, however. And they use what are called functions, which act as what we refer to in Go as receiver functions that represent the methods in the general terminology of object-oriented languages. And also, as I said, it does provide support for interfaces, okay, through interfaces through interface inheritance. However, Go favors containment over inheritance. So you'll have a type that will contain another type, and through that, we build our objects and their related models. So for an example of how we would write a typical object-oriented demo or sample, we might build certain types of shapes just to become comfortable with object-oriented programming. So I might have a circle, a square, a triangle, and so forth. So I wanted to define a circle, and I specify what the key properties are behind that circle. Now my circle type here is a struct, and it represents two inner fields or members. Both happen to be lowercase because I don't want to expose these to the outside world, but I do want to expose the circle type. So you see the visibility, accessibility that's provided by Go is much easier than having explicit public-private notation. We also have, in addition to just the type itself, additional functions that happen to be mapped into or bound to that new type that I've defined. So what this is saying here is that I have a draw method that's associated, bound to the receiver type circle. And this is also telling me a couple of other things. It tells me that the draw function is a safe call and that it will not mutate or alter the state of the object by guarantee. And same for calc area. These are query operations. In other words, they're designed to provide an action or return a value, but they're not designed to alter or change the state of the object. However, paint, where I am passing in a value that represents some color, for example, is a mutator in that it will be able to change the current instance of the state of the circle that's currently in play. And so how do you know the difference? Well, you can see there's one little change, there's an asterisk here. So if you've had any experience with programming languages that have pointer access, then like C, for example, C++, and even C#, where you can use what's called unsafe, you'll notice that is in fact a pointer, but they've really made it easy for developers to use pointers without having to learn the underlying memory access issues that always cause headaches and having to worry about memory leaks and the like, okay? So the main routine behind that simple example would look like this. Notice how simple this is. This says I want to create a variable called shape in the main routine, so I'm not too concerned here with the fact that it's a lowercase s, and I'm setting up the properties of the shape with values, and now I can issue or call whatever methods I feel necessary for my application to perform its work, and then print out the results. So very straightforward, easy to follow. I mentioned polymorphism, so let's take that same example. I mentioned interfaces, so let's take that same example and see how it applies to true object-oriented programming, where we have available to us polymorphism, which means many forms, different objects with the same method name having different implementation. And polymorphism is available to us through interfaces in Go. So interfaces are associated with a special type called interface. And here you specify the signatures of the requirements behind this interface contract. Now, here you build out your types, whatever types might be necessary. For example, I build a square and I build a circle. Now notice both square and circle each have a property. One represents a radius, the other represents a side. And I need a method off of the square so that the square can draw itself, and the same for a circle. Notice that the signature, the function or the receiver function, i.e. method here, takes no arguments, but it has to follow the signature of the interface. Same for the circle. Now in this case, both the draw and the draw of the circle and the square each have their own implementation. And this is now available to us as an implementer of an application to take advantage of the predefined type system. So I created an external function called render, and this is going to take an array, not of circle, not of square, but of anything, any type that happens to implement the method draw. So this now gives me the ability to not be reliant on a particular type having a method that I can call. I'm guaranteed that if render can be called by passing in an object, then that object must implement the iShape interface, which means it has a draw method in this case. The compiler, it's a statically typed system. The compiler will complain if you attempt to pass in anything that does not implement the draw method. So in this case here, I have an array of shapes that I'm defining internally. Now, these can also be passed in by address, and Go would be none the wiser if you wanted to save space. And at this point, I call render shapes. So moving on, so we've seen some key features of the language, very powerful. And Go is also a functional programming language. So functional programming, as again, I read out of Wikipedia, so you see I'm not making up rules, okay? It's a programming paradigm that treats functions as data. So they can be, data can be passed in as an argument to a function call, right? And so a function itself can be passed in as an argument to a function call. That's interesting. So that leads to a decoupling of the procedure that will be called by the function and the caller itself. So the caller decides the rules as to how the called function will implement certain aspects of its program domain. Very powerful capability. So we take advantage of several features of this notion of functional programming. One is very common. It's called a strategy. Okay, so a strategy means the caller determines the behavior of certain features that are built into the called procedure of the called function. Okay, so here's an example. I can define, one of the things about Go is I can define my own types, okay? Literally, I can define a type off of a built-in type, just give it a different name, and that's going to give us all kinds of capabilities here. But in many cases, you'll find that you define your own types just for readability or to limit or constrain the usage of a type, okay? Particularly with arguments that are being made available as formal arguments that can be constrained to a type that you define. So I have here a type called predicate. So a predicate is a means by which we can associate a filtering for our system, filtering or reducing, for example, the set of values that might be outcome in a call procedure. So this says I'm defining a type called predicate that can take one argument of type int and return a true or false, which is a built-in type called bool. And now I'm taking advantage of the functional nature of the Go programming language. There's a significant positive side note to this. Notice that I'm on the right-hand side of the equal sign here, I have a function, but there's no name. It's called an anonymous function. But to the left of the assignment operator, I have a variable, and it's typed to be predicate, which means what's on the right here matches in type to the predicate signature. And so the rule behind this anonymous function is to take an incoming argument and return true if the number is odd and false otherwise. Here is even is the complement to that. I return true if the number is even, false otherwise. At this point, I can take advantage of this type called predicate. It's very simple, in fact. So let's assume that I have a function called apply filter in my application, and I want my apply filter to have as an argument an array of numbers, an array of some type. And I might want to allow the user to pass in some instructions when they call my function that will allow only a certain number of the values inside of the array to be processed. And that's exactly what I'm doing here. So I have a variable that I've defined for my formal argument as the second argument in my apply filter. Okay. Notice again that this is of type predicate. And I'm iterating over, it's a for range in the Go language, which is similar to like a for each in other languages. My for range says go through each of the elements or entries inside of the passed in array and check to see if that value, if that number matches the criteria associated with the called function. So the called function in this case here, is going to return true or false. Yeah, okay. So our strategy in this case will dictate whether or not the number will be printed on output. So how does this all work? Well, let's take a look down here at the function, the main function. So I call apply filter. I pass in, I hard coded the numbers here, 1, 2, 3, 4, 5. My strategy says I want to filter the numbers so that only the odd numbers will be printed. And you notice that isOdd is the name of a variable associated with a function of that type. Yeah. So the name of the function represents the strategy. So if this is totally new to you, you can think of isOdd as being the actual argument that will be aliased or nicknamed strategy. So when we call this function effectively, we're saying if isOdd num, then print the number. Okay. That's the goal of functional programming, and it takes on a life of its own. It's really wonderful. There's a lot more to it, but that's the basis. Okay. And I mentioned one other key feature. In fact, it's one of the highlighted features of the Go language, in that it's a concurrent programming language. Okay, here we are back to Wikipedia again. Okay, I couldn't really find much of note in there. So what they say is it's a formal language for describing patterns of interaction in concurrent systems. It sounds almost like a circular description. All right, so that doesn't get you much. So I had to reword this. In my own words, we'll say concurrency is about dealing with lots of things at once, concurrently, but not necessarily simultaneously, okay? Simultaneous would mean literally spreading out the work over 2 or more different CPUs so that everything runs exactly at the same time, okay? Concurrent might require, in fact, it usually does require some type of a mechanism behind the scenes that would provide a context switch, okay? So Go support for concurrency is, like I said, one of its greatest strengths. However, I always say it's usually one of the last things that you learn in Go, because it's much easier to write a single, I'm gonna put the word thread in here, a single threaded application, okay, even though there's not a one-to-one comparison here with concurrent for Go, okay? It's much easier to write an application that doesn't have to deal with breaking work up into separate components, okay? But once you get into it, it's very, very powerful, okay? So in Go, each concurrently executing activity is referred to as a Go routine. It's an interesting name, a Go routine. And it uses channels as a communication mechanism. So that I refer to it as a means by which we have a sender and a receiver, and in the middle of the sender and receiver is a pipe. Okay, so data is delivered from a sender and received by a receiver. So it allows one unit of work, of one function, to exchange information with another function concurrently. In other words, almost at the same time, okay? So when data is available, it can be received. And if you've worked with any other languages and took advantage of multi-threading or asynchronous operations and parallelism and so forth, you know that it can be very, very troubling when things go wrong, because other languages typically rely upon shared memory and then locking, and Go does not, through Go routines, require that you have to worry about memory locking issues. You can, there is a lower level that you can get down and dirty with Go if you want to, but out of the box, it's not necessary. So here's an example of concurrency in Go. So I mentioned you think of a function as a unit of execution, and we exchange, communicate between these different units of execution by working with what are called channels. So I have a function called generator that has as its argument a channel, and this channel is type safe, which means it can only accept integers. So I can only feed or receive integers from a channel, in this case here called numbers. And I'm pumping numbers into the pipe, so to speak. So I'm going through just a simple example, obviously. It's for the sake of demonstration. I'm going to be pushing out 5 numbers. When each one is available, it will be sent over the channel. Okay, so this one in the real world is referred to as a generator. There would be some time delay in between the data that's being fed out, and it can go on and on and on forever. Okay, as any of you who have worked with Python might be familiar with generators. And I'm going to take that set of values that are being generated by the generator, and I'm going to transform them. Okay, transform means to alter, and so as soon as the data is available from our generator, I'm going to transform it. So I have a channel for taking the numbers in, and another channel for sending the values out in a transformed fashion. So you see that I'm taking the numbers in, hopefully from my generator. I'm going to process the cube of those values, and when the cube is available, I'm going to send it over the channel. And now in our main routine, I'm going to create 2 channels. There's also, by the way, sort of a hidden Go routine in the background that we can take advantage of. It's the main routine runs within the context of a Go routine. So you always have at least one. So I'm making 2 additional channels, and first I fire off the generator function, pass it in the numbers channel, fire off another transformer. Now, when I issue a Go to kick off the generator and the transformer, there's no implicit blocking that I have to deal with. Okay. However, the data will be exchanged because I'm handing off the values from one to the other through this approach that I discussed, where you have data being sent and received over the channel. When I'm done, I print out the values. And you see the output here will be 1, 8, 27, and 64. So I actually have samples of code that will run this, and that is the output. So very powerful. Now, this is not a tutorial on the language. I'm just demonstrating some of the key features to get you a sense that it's not rocket science. As long as you're an experienced programmer, it's something that you should be able to pick up in maybe just a few weeks' time. I would consider that should be more than enough time to become proficient with the language. But I mentioned that one of the goals was to keep the language uncluttered, unbloated. So obviously they had to leave some things out. So what was left out from Go? Well, and this is from other languages. People say, well, does it support this? Does it support that? So there are no implicit type conversions. In other words, it's a strictly typed language. No constructors and destructors that you would normally find. However, there is a special function. I showed you main. Main is a special function. There's also a special function called init, which in a package can behave similarly to the constructor that you would normally work with in object-oriented languages. No default parameter values and no implementation inheritance. You have a quasi interface inheritance that I discussed. And right now there is no support for generics. However, it is a feature that a lot of developers have requested, and it's a very large ecosystem, so developers put in suggestions. Okay. So now, off of the technical mumbo jumbo, we're going to just go through some of the higher level details of the Go language. You might say, well, what kinds of companies are using Go? So here are a list, just to point out some of the names that you, I'm sure, have heard of: Salesforce, Uber, Twitter, Target, et cetera, right? And this is just a small list. I just took a slide. Okay. And interesting, you might say, well, is it a language that has a lifespan beyond a year or two, and then it will fade into the dust, so to speak? So there was a developer survey last year. I have a link on the slide. You can go to that link if you would like. It's a developer survey. And the takeaway from this was that out of the large number of respondents, they agreed Go was working well for them and their teams, and they would use it for their next project. And that's a comparison. There were other languages that were put in that mix of comparisons. So this is a breakdown of the results. Would you prefer to use Go for the next new project? The large majority. Working well for the team. Critical to my company's success. That's okay. That's not necessarily an indicator as to whether or not Go is a language that you really should jump in. This just means within a large organization, is Go a key aspect for the success of the organization? And you would expect that to be low. It's actually higher than I would have assumed. So as you start working with Go, if you're an influencer in your organization, you make suggestions. Say, gee, I'd like to consider this as a language that we can use on the next project. Okay. From a standpoint of getting started, very, very easy to get started. So there's on the slide deck, I have hyperlinks to each one of the aspects of working with Go. So there's a download, you review the installation instructions, and then there's also a tour of Go. So for example, if I click on a tour of Go here, hopefully, there we go. All right. And this gives you on the left-hand side, a small description of one of the aspects of Go, and on the right-hand side, you have a simple program. You can make changes in here if you want. They're up in the upper right-hand corner is a menu. So if I'm interested in learning the language, just as a starter, by the way, notice that it breaks this down into working with functions. And if I click on functions, it shows me an example of code here that I can then click on run. It builds out the instructions internally on a server, compiles, vets, and then executes the program. So some people like to use this as a way to learn. It runs on Windows, Mac OS, and Linux. And on your own, if you wanted to click on the right-hand side, this is also hyperlinked to give you some more information. Now, obviously, you're not going to be programming on the internet. Usually, we have our own local installations. So after you install Go, there's a Go command tool. And when you type Go help, you'll see a number of commands. So what I did here was highlighted some of the, what I'm going to say 4 key commands that you should at least be familiar with. The first one, Go env, that shows you environment, your environment information. Now, another command that's important to be aware of is called get. So I talked about the built-in library and external packages, right? So get, the Go command can be used with go get to bring down the packages that pertain to working with SQLite, for example, a SQL Server or SQL Alchemy, whatever the case might be. There's also one called version, and version will tell you what the current version is. And the most common one that you'll use is called run. So Go run followed by a file name that ends in the extension Go. That will cause the compilation and execution of the application that you wrote. So when we talk about the Go installation, the Go language by itself provides you the key aspects of identifiers, functions, and so forth. But there are other libraries, so it's an opt-in approach. So they have what they call the standard library, and that lets me use, for example, the FMT that I imported. That's called the standard library. So again, that they follow the opt-in approach. If If you don't want to use it, don't include it or don't import it. And so there's a built-in package, which really isn't the package, but that gives you the information that's needed for all of the pre-declared identifiers. Then, as I mentioned, we had FMT. There's a log that gives you logging information. A very important one, if you're going out to the documentation, is to look at the OS import, and that provides platform independent interface to the operating system. For example, I can get the environment variables with OS. I can get command line arguments with OS, and so forth. So there are many, many others in Go. In fact, if you notice, I also have a hyperlink here, and this gives you a little breakdown as to what the different packages are that are included with the language. So down here, you'll notice there's net, which contains an HTTP package. So that means that HTTP uses the features that are provided within net as an abstraction to dealing with, for example, getting URLs and request responses if you want to build out your own web server. Very, very powerful implementation of features that you want to take advantage of. We're mailing SMTP, there's OS. Working with the file system, they give you a path, runtime access, sorting features, built-in testing. The testing is phenomenal. Very, very simple to learn. It's not you don't have to learn a complex framework to test your code. Time is available. And interestingly enough, they also have a package called unsafe. It's considered to be unsafe to have to query about memory. For example, if I want to know the size of a structure, I have to import the unsafe package. That's supposed to be basically stuff that you don't have to worry about, because memory allocation might change in future releases, right? So now, I mentioned that there are other packages that are available in the ecosystem, third-party packages. So down here, notice that I have Zap and GoBot and database. So I can literally find any package that provides features that I might be interested in using for my application. And what you would do after you find the one that you're interested in, you use the go get command and specify its target. The majority of these you'll find are going to be retained on GitHub. Now, I mentioned that there is a tutorial that I showed you could walk through. It'll take you maybe a day to go through the whole thing. You can also take advantage of what they call a Go Playground. The Go Playground is here for if you don't have an implementation of Go on your computer. I find that to be useful just for some quick demos, but I personally never use it, but it's there for us, and I have a hyperlink to that as well. For local coding, you have a structure that you need to adhere to. So inside of your directory structure, you have a root directory or a root drive, for example. You might have a folder, in this case here, Go Dev. Under Go Dev, you'll create a folder called SRC, and under SRC is where our folders that contain our projects will live, including any of the applications that rely upon other projects. So there's a need for you to understand that requirement of hierarchical structuring for your applications to work. Okay. Now there are ways in which we can build out an application without having to have a structure like this. But if you want to do anything that required additional packages that you write, then Go would use this as a means by which you would locate the packages. And then the Go path is also important. So Go path lets you specify on Unix or on Windows what the root directory is for your projects. So here on Windows, I actually have a Windows machine set Go path equals C::Go Dev, and that would map into here. And then when I run my application, it will look inside of the source root. And this goes back to the first procedural example I showed you. Editing your applications can be done in any text editor. However, most developers will use IDEs, integrated developer environments, and it makes your day-to-day tasks of building and maintaining and testing code that much easier. They provide IntelliSense, quick help, built-in compilation features, debugging support, and the like. So there are a number of them that are available. I happen to be a big fan of Visual Studio Code. It was written by Microsoft, and it's cross-platform, so it works on Linux, Mac OS, and obviously Windows, and it's free. So why not if it's free? But there are others as well. You could even use Sublime Text or Notepad or VI if you're interested. Okay, it's just that I think that having a true Visual Studio Go code example, for example, at my fingertips makes life easier as a developer. So, as I mentioned, the IDEs give us many advantages at the cost. There is a small cost in that you have to, they're sometimes going to be somewhat slower. All right, some people find it easier to use Sublime Text, right? So here's an example of what Visual Studio Code would look like. So on the left-hand side, we would have a pane that showed all of the projects in folders, and then we could just open up a particular file and start coding. You can go to View and open up a terminal window. They have a built-in debugger and so forth. So here's an example of, notice the color coding. So built-in example that I wrote that says "Hello World." Yeah, okay, very, very simple to use. So in summary, I will have to keep this under an hour. In summary, I say go for it, right? So we went through at the very first, one of the very first slides, I showed you the initial page, the initial web page, and as I said, it hasn't changed, right? So here it is, 13, well, it was 2009 or so, but it hasn't changed in 11 years, right? It's simple, fast, safe, concurrent, fun, and open source. So go for it. And any questions? Any questions? There's a question and answer section. By the way, I did introduce myself. I'm going to go ahead and put my name again in the chat window. Then you can obviously always contact me through a web page solutions, and I'll put in my email address for you as well. That way you can reach me. If you have any questions, as I said, the slides are available to you. I put them in the chat window this morning, plus they were made available through WebH Solutions. And also the audio, the recording should be made available shortly. And I don't see any questions. Well, that's good. That's good. Well, I hope everybody enjoyed the presentation. Like I said, feel free, anybody, feel free to send me an email with a question, with any questions you might have after you reviewed it. Wonder the way to get started, for example, and be happy to help you out. And on the next page here, I have an outline link to the course. This will bring us right to the website for WebH Solutions. And as I said, it's a brand new course. It has been run as an on-site, but so I don't think that it's currently on the schedule, on the course schedule. But if you are inquiring, just contact WebH Solutions and tell them that you're interested in taking a course, and I'm sure they'll put one on the schedule for you. I just wanted to quickly go through here and notice the outline of the course. We start off with a quick introduction to Go, which is basically what we covered in here, except I do more interactive, right? We actually open up the web, download the Go language, right? I show you how to navigate. So some of the things I just discussed here, and I do some simple examples in class. And then we get started learning the language, talk about the data types, work with arrays, slices, and maps, user type struct that I mentioned, building out functions in many different aspects of working with functions, recursive functions, closures, anonymous functions, and so forth. Error handling, totally different in Go than it is in any other language that I've worked with. It actually took me a little getting used to, trust me. Methods, interfaces, I/O, and networking. We talk about, in addition to simple file input, output with text and binary, also talk about serialization, JSON and GOB serialization, or binary object serialization, interfaces and how they are made available to us for HTTP. And lastly, we talk about working with REST, representational state transfer. And in the last module, we cover Go routines and multi-threading, okay? So if there are no questions, I will close out the session and want to thank everybody for attending. Really appreciate having you all on board. So thank you so much. Thank you. Bye, everybody.